It's all about the data. There's an immense amount of data that describes a Tier 1's network's topology, resources, and services. This data is distributed across a myriad of operational support systems, each of which only holds a partial view, and where there's overlap, it's completely inconsistent. It's amazing how when we go out to work into real telecom operations environments and study their data ontology, the true master source of the data is held in spreadsheets. Sometimes I feel like Microsoft Excel is the industry's leading operational support system. When you try to automate on top of this bad data, you just get fallout, requiring it to be done manually. When you run analytics to understand the operational state, performance, or capacity of the network on top of this bad data, you just get conclusions that nobody trusts. The bottom line, there is no viable information model serving today's networks that can be trusted. The business impacts of this are pervasive. Ethernet circuit turn-up time is measured in weeks or months, when in most cases it should be seconds. And in today's interconnected world, services are increasingly inter-carrier. They're extremely hard to orchestrate, which impacts new business. Authoritative SLA monitoring of services between parties is a manual exercise, often based on trouble ticketing between the parties, requiring human study. And this can lead to SLA penalties and customer churn. The mean time to repair of network issues is significantly extended because of difficulties trying to sectionalize and triage faults. And the user experience issues can result in customer churn and lost revenues. You hear a lot about big data these days. In the context of telecom operations, what this means is that today's software and computing technology allows a level of data centralization, consolidation, and analysis that was not possible in the past. CENX believes that what's fundamentally required is a service orchestration system holding a unified services information model sitting above today's operational support systems. It brings all this data together. This includes intelligence such as Ethernet circuit inventory, where it's located, who's providing it, ordering details, etc. This data can be mined from any source, an existing OSS system, a spreadsheet, an order activation, an SLA contract, or even the network itself. We then apply data analytics to audit, reconcile, and correct this data. In this way, we correlate these fragmented data inputs into a comprehensive services information model. With this in hand, we can do some really interesting things. We can build a picture of the network right down to the circuit details. This allows you to visualize your services in a single view that alleviates the need for swivel chair analysis trying to scrutinize multiple screens at any one time. We can automate to drive the cost out of operations and dramatically improve service agility. We can analyze the data to provide detailed reporting and measurements to improve the user experience, determine SLA performance, and plan for capacity upgrades. And finally, we can manage the transition to a software-defined network. We do this by integrating downward into SDN controllers or virtual network functions, since services will certainly cross between the old and new infrastructures for what's certain to be a long transition. Let me give you some examples of what we've achieved with our Tier 1 service provider customers. 70+% improvement in inventory accurate, 80% plus reduction in service turn-up time, 20% plus improvement in operation savings. The ability to triage a network fault in a few seconds, what used to take 30 minutes.